Hello. So today I want to talk about Simpson's paradox, which is a very big paradox that could appear in statistics. Let's jump right to it. Okay. So I think probably the best way to introduce this paradox is just looking at an example right off the bat. Um, for this worksheet, you're definitely going to need some kind of calculator. So please feel free to pause the video and pull one out, or use your phone app calculator and compute along with me, because I want you to be able to do this for the worksheet and also in the quiz. Okay, so let's say we are looking at two baseball players, Major League Baseball players, and we're looking at their batting averages for two different seasons, so 1995 seasons and 1996 season. So let's say we're looking at this Derek Jeter versus David Justice. Let's say you are considering drafting them for your team, and maybe they're comparable salary wise. So let's see who you would hire based on what their batting average is. So let's uh, compare what their batting average is for the 1995 season. Okay, so for Derek Jeter, 12 hits out of 48 at bats. So that's 25% of hit. For David Justice, it's 104 out of 411, which is slightly about 25.3%. Okay, so if you look at 1995 season, David Justice does a little better. Let's look at the 96 season. Derek Jeter does 183 over 582, which is 31.4%. And David Justice does 45 out of 140, which is 32.1%. Okay, so 96 season as well. David Justice does a little better. They both improved, but David Justice did better. So if you look at this season by season, it seems to me that David Justice has better batting average. But actually, if you look at the overall batting average, the situation flips. So let's try to see what Derek Jeter did for the two seasons that we've looked at. So we could look at the overall batting average. So 12 hits and 183 hits. So total of 195 hits out of 48 plus 582. Let's type that in a calculator. Okay, so overall, the batting average of Derek Jeter for the 2 years is 30.95% of getting a hit. And let's look at the overall data for David Justice. So 104 plus 45 is 149 total of hits, and total attempt at bats are 411 plus 140, so that's 551. Okay, and that is about 27.0%. Notice that David Justice had a lot more at-bats on 95 season where both players were doing worse. And Derek Jeter had a lot more at-bats um, in the 96 season where both were doing better as well. So the combined average was leaning towards bad or the good years overall, and you get the different batting average overall. So this is what the Simpsons paradox say situation. If you group it into a certain category, it may look like one is better than the other for each of the categories. But if you kind of average overall performance, sometimes even though one seemed to be doing better overall, so for each category, overall it could be actually the opposite situation. So when something like this happens, there's a little more careful analysis of like what's happening behind the data is necessary because it's telling you two different things at once, right? If you want to hire Derek Jeter because it's overall better batting average, um, or would you rather hire David Justice, who did better each season? It might depend on whether maybe they were injured at a certain season, or maybe you want to look at who did better in a recent season. All these could come into play when you make the analysis, but it's not clear cut overall. Which is a better way to look at this data? You really need to look at why the data is saying that. So I would like you to pause this video and fill out the first half of this worksheet, working through this example with the batting average. And there's another more involved example involving two hired assassins who make certain amount of kills based on certain number of contracts they were hired to kill in each year, and kind of walks you through similar process. Like, hey, which is the better assassin from year to year, and which is a better assassin overall, and what you think happened, and who would you hire if you wanted to kill somebody, and you want that assassin to succeed. So I want you to try this half of the worksheet as well, and kind of come to your own conclusions about how to explain what's going on here. Is it always better to look at overall, or does it make sense to look at category per category? Which do you think gives you more information? And is there a better way to look at it in every situation? Or if you can think of a way how to resolve these two paradoxes that we discussed on this worksheet, let me know. All right, I'll end this video right here, and I'll see you later.